Hi, this is Maggie. In this video we're going to continue with our surface and event handling raccoon program. Now, what we have already constructed is a program that draws a room with a randomly located raccoon in it. The room and raccoon initially start out dark. The program responds to a mouse button up event by toggling between dark and light rooms. When the program toggles to a light room, the raccoon is moved to a new random location. Now we will change our background to be the outside of a house. And we will blit images of rooms so it appears the user is looking through windows at the rooms. This will involve setting clipping regions. We will blit the outside of the house, and then we will blit these other images, which is the 4 inside rooms, a light version and a dark version. And we'll begin by programming something very similar to what we already have. When the user clicks, the rooms will toggle between light and dark. After we have that working, we'll work on turning the lights on in the room in which the user clicks. So one question is, how do we represent the windows so that we can use them as clipping regions, and so that later we can determine whether the user has clicked within them? And a good answer is to represent them as objects of the pygame rect class. I've used my drawing software to find the coordinates of each of the 4 windows, and I'll begin by annotating the 4 windows as pygame rect objects, and then instantiating them with the coordinates. So that looks like window upper left equals pygame dot rect 88 36 184 160, for example. And I'll pause the video and define all 4 rectangles, and then I'll come back. While I have the video paused, I'm also going to annotate and load the new images and remove the old ones. So I'll add the image for the outside of the house, which I'll call outside, and I'll add the images for the rooms, which I'll call dark rooms and light rooms. Okay. And we're back, and I also added a caption, so there are instructions to the user. Now, one thing that's going to make my life easier is putting these window rectangles in a list. So I'm going to do that, and I'm going to call the list windows. Now, here's why. I want to draw my room's image through all 4 of those windows, so I'm going to have to set each one as the clipping region and blit my room's image 4 times. It will be easiest to do that in a loop, which I can do if I have my windows in a list. So I'll remove the old drawing code, and I'll blit the outside image. And then for window in Windows, And remember that a window is a pygame rect object, which is what I pass as an argument to set clip. So within that loop, I'll write screen.set clip window, and that will set the clipping region to one of the windows in the list. And then I'll blit a variable called blit rooms, and then I'll blit the raccoon just in case he's visible through that window. I'll have to keep blitting him because I don't know where he is. I suppose if I were going to be really efficient, I could check to see if he's actually in a room before blitting. I'll show you how to do that in the next version of this program, and then you can make this more efficient if you want to, although I'm not sure if checking for rectangle collisions is a lot more efficient than blitting a small image. Probably is. Okay, and there are some variable names I'll need to change up where I'm checking for the click, because I now have rooms that I'm blitting and not a single room, and it's just a variable name change, but I don't want any errors. Okay, so to review, I haven't really done that much. I've really just changed my background image to be two images, the outside of the house and the inside. And I'm using those two images with a set of rectangular clipping regions to make it appear that we're viewing the inside of this very weird house through the windows. But the rest of this is basically the same. And I say the house is weird because one of these images that I found is called the monument room. Like, we all have a monument room in our house, right? Yeah, that's where I keep my Greek statuary when I bring it in for the winter. Okay, so let's run this. And there, you can see my 4 rooms, and if I click, it toggles the lights on, and if I click again, it toggles the lights off. And the raccoon moves around randomly, and sometimes he's not even visible because he's in the space between windows. So the next modification is to have the program respond to a click by checking which window it's in and turning the lights on in that room and off in other rooms. Now originally I wanted the raccoon to flee a room with the lights on, but if he does that we'll never really see him because it's hard to see him in the dark. And since we're practicing what we learned in the chapter, I thought it would make more sense for him to play possum, flip upside down with his paws in the air if the lights come on in the room he's in. So we'll do that. So to do this, let me show you a couple of methods in the pygame rect class. Here we have collide point and collide rect. If you pass a point to collide point, it will return true if that point is within the rect. Do you see how handy that is? The user clicks in a window and I can get the location of that click from the event. I can then ask each window if the click is within it, because the windows are pygame.rect objects. And if it is, I know I want that window to light up. I can use collide rect to see if the raccoon is within that room by checking to see if the raccoon's rect is colliding with the window rect. So we will use these two handy methods, and that will mean we won't have to do that little bit of math ourselves. And we shouldn't shy away from a little bit of math because it's fun to figure things like that out. But when there's already a method to do exactly what you want, you should use it. A method that's part of a library has been extensively tested and so is most likely correct, and it's also possibly more efficient than what we might write. Now I'm going to need to keep track of which room is lit. Remember that I have a list of windows that are pygame rect objects. So I can keep track of the lit room by storing its index, and I can initialize that to -1, which will represent no index or no lit room. I'll call that light index. So down in the drawing, I'm going to blit the outside of the house as I did before. And I'm going to iterate through my list of windows, but I want to blit the lit rooms when I set the clipping region to the lit up window, and I want to blit the dark rooms otherwise. So I'll iterate over the indices instead of iterating through the list of rect objects. So for I in range len windows, and I'll set the clipping region to Windows sub I. Then I'll check if I equals light index, and if so, I'll blit the light rooms. And if not, I'll blit the dark rooms. And then after the if statement, I'll blit the blit raccoon. Okay, but how is the light index set, and how is blit raccoon set? That will happen back in the event handling. So we'll go back to where we handle pygame.mouseButtonUp, and we'll iterate through the windows. For I in range len windows. And we'll use that collide point method to find out if the user's click falls within any of the windows. So if Windows sub I dot collide point open paren edict sub pause then light index equals I. Okay, let's pull that apart. The list of windows is a list of pygame rect objects, and we can send the collide point message to a pygame rect object to find out if a point is within the rectangle. So Windows sub I is a pygame rect object, and then we use the dot notation to send it a message, and then we type the name of the message, which is collide point. We're asking the specific rectangle, is the point passed as a parameter within your boundaries? And then we pass the point edict pause, which is the position of the mouse at the time of the click, the position of the mouse that is stored in the event object. That's going to return true if the user clicked in the particular window to which we sent the message. So if it's true, we set the light index to the index of that window. It's possible the user has clicked but outside of a window. So sometimes we'll be turning the light on in a room, and sometimes we'll be leaving the light on in a room if they've clicked on the house but not in a window. Every time the user clicks, we're going to move the raccoon. So we'll begin by randomly generating a new location for the raccoon. We then need to find out if the raccoon is within the room that's lit up. If he is, remember he's going to play possum when the lights go on. So we'll use the collide rect method this time to find out if there's overlap between the window indexed by light index, the light window, and the raccoon's rectangle. We'll use the raccoon X, raccoon Y coordinates, and then we'll get the width and height of the raccoon's image to construct the raccoon's rectangle. Okay, if that's true, we're going to set blit raccoon to the light raccoon, but a transformed version, a flipped version in the Y direction. So, pygame.transform.flip light raccoon false true. And if not, then we'll set the blit raccoon to the dark raccoon. Now, we no longer need to keep track of this Boolean variable dark because we're not toggling and we're not setting the whole image to dark or light. So we can remove that. And we can remove the code in the event handling, which flipped the switch from dark to light and vice versa. Okay, let's give this a test. I'll turn the lights on in one room and then click outside the room. And if you're observant, you can see the dark raccoon moving around, and every once in a while he will move into the light room where he is flipped upside down. And I can also click on other rooms to change which room is light. Okay, so that's a project that incorporates a lot of the Pygame tools that we've learned about, but it also uses good old-fashioned programming logic, variables, and programming structures to get the job done. Here we stored the window rectangles in a list, and we stored an index to the room that is currently light in order to manage blitting the correct image to the correct window and blitting the correct raccoon. I'm sure you have your own ideas for what you might like to program using these constructs. Have fun with it.